Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrell's Algebra 2 class. Today we're going to wrap up chapter 4. We learned about functions. We learned about domains, ranges. We learned about the three forms of linear functions, which are slope-intercept, point-slope, and standard form. We learned about x and y intercepts, how to graph a linear function with an x and y intercept, how to graph a line using a table method, using the slope-intercept method, even using the point-slope method by getting the point that is given to you and then following the slope from there. We learned about parallel and perpendicular lines and the relationship of their slopes, and we learned how to write parallel and perpendicular lines when given one line and a point. So we've learned a lot. Now the good news is the last of it, and even better news, all of the skills you learned before are going to be used the same way right now in today's lesson. And today we're talking about inequalities. We've seen inequalities before, guys, with one variable. You've seen x plus 5 is less than 7. We know how to solve that. We know how to graph that. We know how to write that in interval notation. Today we're solving inequalities with two variables. Whenever we have two variables, an x and a y, that means that there's going to be some sort of a graph. Okay? But remember, when x has a power of 1, when x is raised to the power of 1, it's linear. So these are all linear inequalities. And when working with linear equations, or inequalities rather, should have started out very poorly here, I apologize. That was very bad. This is inequalities. Or actually, no, I was right. I'm so silly. When working with linear equations, every ordered pair point directly on the line is a solution of that equation. However, when solving linear inequalities by graphing, there will be an infinite number or infinite amount of solutions. So you must shade in your solution set or your solution zone based on the boundary. Now, whenever you look at a book to teach you this, most teachers follow what they say, and what they're saying is absolutely correct, okay? When they give you an inequality, they want you to graph. To figure out if you have to graph above or below, they want you to plug in points, guys. They want you to plug in what's called the test value. Okay, test to see if it's above the graph or below the graph. If you make that test point and it works, well, then you chose correctly, shade. If not, you got to choose another test point. There's nothing wrong with it. That is the real perfect mathematical way to do it. I think it's inefficient, and I don't think that it's very valuable, really, unless you just can't see it. Unless you have maybe 5 inequalities going on at the same time, maybe then I can see the usefulness of plugging in values. But I'm going to teach you right now how to shade, okay? Look at my red shade above. Okay, if I see that y is greater than x, I look at the y-intercept, my brothers. The y-intercept here is 0, right? So what's a greater than 0? Above the 0 or below the 0, which is greater? Above. So when it's y is greater, then you're going to shade above the line. I don't care if it's a positive or negative slope, because look over here. When y is greater than a negative x, you still shade above the line. So I don't do this whole shade left, shade right, shade, no. It's either shading above the line or below the line. Sir? Well, if you get a vertical, then that's even easier. To the right will be larger, greater. To the left will be less, right? If you get a horizontal line, above will be greater and below will be less. But when you get a regular inequality, above or below, what do I do? What do I shade? Literally go by your y-intercept, basically. If it's, look at the blue, if I shade below, it's because y is less than x. That means that my y-intercept is 0. Going below it, underneath it, will be less. And that's how you shade. It doesn't matter if you have a positive or negative slope. If you have a y is less than negative x, I'm shading below as well. If it's greater than or equal to or less than or equal to, the same exact rules apply, except if it's greater than or equal to, it is a solid line. That means that the points on the graph are also solutions. If it's y is greater than or equal to, you're going to shade above the graph, above the line. Doesn't matter if you have a positive or negative slope. If it's y is greater than or equal to, solid line, shade above. If y is less than or equal to, solid line, shade below. Even if there's a negative slope, shade below. So please, don't do, oh, it's left, right. No, 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 no. Don't even do up or down or anything to help you memorize. Read the function and find the y-intercept. From there, you'll know whether to shade above or below the line. When you're shading, though, please, guys, check this out. I know this is one of, Mr. Morrow's technicalities, but it's something that, trust me, is going to help you out later. When people are shading, this is how most people were taught to shade. This is not your fault. People go like this. And that's fine. There's nothing wrong with that. There's nothing mathematically illegal. However, when we further go on to systems of two systems of equations, you're going to have simultaneously here, guys, another line. Okay? And maybe you'll have a line going this way. And you have to see where both shadings intersect. If you shaded like this, and then you shaded this one like this, do you have any idea where they intersected? No. However, if you shaded first time like this with straight lines, and then you shade this one, do you see clearly where the intersection is? Right here, right? Where you have the checkerboard. Thank you. That's why I do it this way. So I'm going to train you from now, when you're shading, shade with nice straight lines. I don't have to have 5 billion of them. I need more than one or two, of course, too. But please do not just make a messy shade. Please. Okay? Does that make sense so far? Okay. The rest is a joke now. Graph each linear inequality. Is this Mickey Mouse time? What's my y-intercept here? -2. You darn right. Thank you. So -2. What's my slope, my brothers? 3/1. So I'm going to go up 1, 2, 3/1. La, 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 la. Love it when it happens. 1, 2, 3/1. 1, 2, 3/1. I got to go backwards. So I'm going to go down 1, 2, 3/1. Is this going to be a solid or a dashed line, my brothers? If it's greater than, it's going to be dashed. So you dash to the best of your ability. Now, the piece de resistance. Am I going to shade above or below this graph? It's greater than, right? It's my y-intercept, right? So I'm going to shade above it. Shade above the graph if it's greater. If it's greater than, you shade above. Look at this. Mr. Morrow had an epic fail. Epic fail. -2 is here. Mr. Morrow learned how to pay attention. 1, 2, 3/1. 1, 2, 3/1. Down 1, 2, 3/1. That was embarrassing. Thank you, my brother. Now, shade above or below? Above. Does that make sense? Gentlemen. Everyone, this makes sense. Okay. Number 2. Y is less than or equal to 3. Whoa, what kind of a function is y equals less than or equal to 3, my brother? What kind of a function is a y equals? What is the graph going to look like there, my man? What is the graph of a y equals function going to look like? No, but good try. I'm proud of you. Good try. Who else wants to help him out? What do you get when you get a y equals function? Yeah, it's a horizontal line because that means that y is 0. The slope is 0. So I'm going to do a solid line because it's less than or equal to at 3. Solid. Now, am I going to shade above or below this guy? Below, because it's less than or equal to solid line. Does that make sense? You with me, my brother? And remember, the x equals is a vertical up and down. Okay? Thank you, my man. Remember, one way I always remember this, guys. Do you see x anywhere here in the equation? So you're never going to see x in the graph either. You're never going to hit x. Just like if it's an x equals, do you ever see y in that equation in an x equals? So you're never going to touch y. So it's vertical. Okay? Thank you, my brothers. Let us continue then, please. Okay, next. Ooh, what do I do here first, guys? What do I do here? Yes, sir, my brother. Yeah, you're going to solve for y. I'm very proud of you, kid. So then I have 4y is less than negative 5x plus 12. Then what, my man? Heck yeah. Okay, very good question. I'm not being sarcastic, and I'm proud of you. The question was, do I change the inequality? Did I multiply or divide by a negative? Okay, so then no. Thank you for asking. Again, I was not trying to be sarcastic. Thank you, son. You got it, brother. Now, what's my y-intercept? 3. So I go 1, 2, 3. Pay attention this time, Moro. That is correct. Yes, it is. What's my slope, gentlemen? Negative 5 over 4. So I'm going to go down 1, 2, 3, 4, 5. Run 1, 2, 3, 4. Always run to the right. And then I'm going to go backwards. Up 1, 2, 3, 4, 5. 1, 2, 3, 4. So you always run to the right. Let's go backwards. Dash that up. Now, am I going to shade above or below? Y is less than. I'm going to shade below. Does that make sense? Got it? For sure? We doing good here, gentlemen? Okay. Oh, okay. Let's see. Let's separate the A's from the B's here. Okay, thank you, my man. I took the word out of my mouth. This is the point slope form. You could go ahead and solve for x here. I mean, for y. You can, but why would you? What's my x1, y1 here, brothers? It's 4, comma 3. Remember, these are opposites. So isn't that a point on the graph? So go to 1, 2, 3, 4, 1, 2, 3. What's the slope, my brothers? 1/2. Up 1 over 2. Up 1 over 2. Up 1 over 2. Down 1 over 2. Down 1 over 2. Dash or solid? Solid. It's greater than or equal to, above or below? Now, all joking aside, isn't that easier than solving for y first, my brother? Now, could you have done it by solving for y here first? Heck yeah. There's not a darn thing wrong with that. But the whole point of math, guys, is not just doing what the teacher tells you. It's being able to truly understand the math so that you can manipulate it so that it works best for you. Yes, sir, my brother.
I solved for it. I got y is greater than
Okay, let's see. Let's see. We've got, yeah, you did your math wrong. But that's okay, and I thank you for that. So in fact, instead of thanking you, empty thank you, let's show you what we did wrong, okay, my man? If you were going to solve for y here, this is y minus 3 is greater than or equal to 1/2 x, because you have to distribute, my brother. 1/2 x minus 2. Now you add the 3, and y is greater than or equal to 1/2 x plus 1. So no, my y-intercept is correct. My slope is correct. Okay, yeah, because I think that what you did, my man, is you added 3 to the negative 4. And there is no negative 4. You have to distribute first. So thank you for that. Thank you very much. You're welcome, sir. May I continue, gentlemen? All right. Okay, now for this one. Don't be afraid, okay? I don't mean that sarcastically. You've got the skills. First of all, it's a dashed line, and there's shading above. So what do you know right off the bat? That y is greater than. Very, guys, great start. Give yourself some kudos for that. Good job. At least you understand it. Now, let's really get excited over getting the right answer. What's the y-intercept here, my brothers? You're darn right. So that's my b. Now, what is my slope, my brothers? I went down 1 over 1, 2, 3. Oh, yeah. So my slope is negative 1/3. Well, guess what? Now I'm done. Y is greater than 1/3 x, thank you, plus 4. Bada bing, bada boom, and you're done. Makes sense. Okay. How about this bad boy for B? What's my setup going to be here? Y is blank. Y is less than. Very good, because I shaded below and I'm going dash line, so it's less than. What's my y-intercept here, my brothers? Yeah, negative 2. Very good. So B is negative 2. And what's my slope, gentlemen? From here, you may see it on your paper. It's right here. Is it 1? Let me see. 1, 2, 3, 4, 5, or 1, 2, 3. Yeah, it's not 1 over 1, guys. Because look, let me see if I can help you out here. Let's see what we can do here. Look, check it out. Hold on. Let's check it out. Okay, yeah. See, it's not going through the crosshairs, right? Guys, think of, I hate to make this analogy, but think of the video games that I so do not like, where, you know, you're a soldier or something and you're a sniper. You want the object that you're going to hit right in the middle of the crosshairs, right? Not near it. You want it in the middle, right? Well, that's where a perfect point is. So there is no perfect point here. Yeah, there's no perfect point there. So the perfect point is the one that I had said prior, and that's this guy over here. So I went up 1, 2, 3, 4, 5 over 1, 2, 3, 4. That's a perfect point. So that's 5/4 x. It's my slope. Minus 2 is my y-intercept. Again, guys, be careful. There's not a perfect point there. The perfect point is right here. Just below it. That make sense? Thank you, gentlemen. Thank you, thank you, thank you. Okay, and all right. Now, word problems, your favorite. There are key words that are going to really help you out in inequalities, guys, and it is at most. Whenever you see an is, you know that you're talking about an equation or an inequality. Why do I care? Because I can say x more than 5. X more than 5 is just x plus 5. But if I said x is more than 5, then x is greater than 5. That is makes it an inequality. Please be cognizant of that. But if I say is at most, it's less than or equal to. Think about your ages, guys. You guys are all at most 17 in this room. That means you're 17 or younger. So that's why it's less than or equal to. At least is greater than or equal to. I'll put myself on the block there. Mr. Morrow is at least 35. That means I'm 35 or older. Okay? So is at most less than or equal to, is at least greater than or equal to. If I just say is less than, that means you have the less than sign because of the is. Is more than, that means I have the greater than. Does that make sense? Promise? All right, now watch the magic, guys. County fair. Okay, at a county fair, small rides cost three tickets, and large rides cost 5 tickets. Tickets cost 25 cents each. How many small or large rides can you ride if you want to spend at most $15. Well, label, 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 label. I'm going to call X the small tickets. Do I have to call X small tickets, guys? I can call it whatever I want. Small. Hold on. 3 tickets per. Yeah. Boy, I'm off today. Thank you, kid. I do mean small rides. And Y is large rides. Definitely label, 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 label. Now, how many tickets is it for every small ride? Okay, so check it out. You got 3 tickets for each small ride, right? And 5 tickets for each large ride, right? And tickets cost 25 cents each. How many small or large rides can you ride if you want to spend at most $15? So you tell me, guys. I'm sorry? No. 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 It's 75 cents for every small ride. Is it not, guys? Because if it's 3 tickets each and it's 25 cents each, isn't it 75 cents for each small ride? Plus, how much for a large ride? $1.25 for every large ride. Why? And this, I want to spend at most. So at most is less than or equal to $15. Now, you want the easy way or the super complicated way? Okay, we're dealing with money here, right, guys? So, guys, if I wanted to go ahead and find a slope for all of this, it's going to be pretty ugly, and it's going to be a lot of work. So what Mr. Moro does whenever he's using inequality word problems, I just use my x and y intercept. When y is 0, guys, what's my x-intercept? 15 divided by 0.75, that's going to be 20. So 20 comma 0 is my x-intercept. My y-intercept, if I make x 0, 15 divided by 1.25, I believe is, come on, divided by 1.25, yeah, it's 12. So this is 0 comma 12. So now, check out the beauty of inequalities. The x-intercept is 20. Let's go by 2's. So this over here is my 20. My y-intercept is 12. Let's go by 2's. 2, 4, 6, 8, 10, 12. I'm going to use a dash or solid line? Solid line. Why do I stop there and not move on into the other quadrants? No, it's not because I don't have to. It's because I can't, guys. Can I have negative 20 rides? Can I have negative money? So I cannot go into the negative quadrants. Now, am I going to shade above or below? So guys, guess what? You're done. Motto, what do you mean I'm done? Any point you pick inside of this region will be a possible combination of the number of tickets you can buy. Heck, if you want, you could just right off the bat buy 20, go on 20 large rides for that much money. Oh, I'm sorry, small rides. Or I go on 12 large rides immediately. Yes, sir.
But doesn't the question say how many small or large? It doesn't say combination of the two. It just says small or large.
Yeah. How many small or large rides can I ride?
What did you have to do separately? Large and separately.
Now, because like right here, for example, this is 1, 2, 3, 4, 1, or actually 2, 4, 6, 8. So this is 8 and 2, 4. So in this one, I could have written 8 small and 4 large, or I could have done 2 and then 2, 4, 6, 8. I could have done right here 2 small or 8 large.
Yeah, but you can't do 20 large rides. It says or.
Yeah, you can. You could do 20 and 0.
But in a 20 large rides would be
I'm sorry, these are small rights.
Yeah, that's what I'm saying. You can't do 20 large rights.
No, you can do 12 large rights.
Yeah, that's why you have to do.
So you, or you could do 0, comma 12. So each of these are ors. You could do this, or that, or this,
But you didn't.
or that.
I'm sorry, I didn't see that.
No worries.
Yeah, because if you're doing or, you have to do like differently.
Yeah, I know you got a label.
Yeah. Okay, I see that.
Thank you so much. Correct. Correct. Thank you, my brother. Guys, please settle down. Okay, listen up. We got one more. The bell's about to ring. I know you're not going to listen to me. I'm going to not only ask you, but I'm going to check this tomorrow in your notes. I want to see this one done on your own. Thank you. I know you can do it. Homework's valid. God bless you all. Hope you learned a lot. Thank you and have a great day. Bye-bye.